Everyone's talking about AI agents right now, but let's be real, most of what is called an agent today is just a glorified workflow in disguise. So let's break down number one, what actually is an AI agent? Number two, when should you build one? Because I think these are two key questions. Over the past year, teams across various industries have tried building agents, and you know what Anthropic found? The most successful systems weren't complex, autonomous mega agents. They were simple, they were modular, and they were easy to understand. And that is what this video is about. Getting clear on what agents really are and how to build smart agents without over-engineering. Anthropic defines it like this. Workflows equals LLMs plus tools, orchestrated by predefined code paths. So this is a workflow. An agent, on the other hand, is an LLM that is dynamically directing their own tools and processes. In plain English, we can say that workflows follow instructions. But on the other hand, agents are all about making decisions. And let's put that here, making decisions. So that's the key difference. A workflow is all about instructions, while an agent is about giving the entity, the AI, the ability to make its own decisions. And I think this is a key differentiation, distinction that you need to really understand. A workflow is like a checklist. An agent is like a human assistant. It can ask questions, it can handle new situations, and it can also improvise. And that one distinction really changes everything about how you build your AI-based flows. At the heart of both workflows and agents is the augmented large language model. And that means a model that can, number one, use tools. Number two, it can retrieve information. And number three, it can store memories. And in many cases, you have also a number four. It can respond to different environments. And this is your real building block. Whether you're building a basic bot or a full-blown agent, this applies in both situations. Before you go full Skynet, try these approved Anthropic patterns first. And these are mentioned in their guide, in their documentation, in this article right here. So they have this complete article, which I'll link to in the description, which is about building effective agents. And it goes through a lot of these different frameworks. So you have the building blocks, you have then the different frameworks. So we have prompt chaining, we have routing, we have parallelization, orchestrator workers, and it's a very interesting article and gives you a lot of ideas about how you could potentially build your workflows. And these are the top ways, the top flows that I have found to be the most useful. And when you break these tasks into the steps that they mention, you can then use large language models to move step by step within the different checks. For example, if you are outlining, then validating, and then writing, that is a clear three-step process to getting an article ready, where you have the outline, then you're ensuring this is what you actually want, and then you have the AI do the writing. The second flow is routing, and this is based on a specific input type. If we go back here and we look at routing, this is classifying an input and directing it to a specialized follow-up task. This workflow allows for separation of concerns and building more specialized prompts. Without this workflow, optimizing for one kind of output can hurt performance on other inputs. And this is key. You don't want to sacrifice your output at the expense of making things seem simple when you are creating. So here you would use this for anything like support tickets, tiered models, input handling. There are specific situations where this routing option really works well. Then we have parallelization, and here the aim is to let models work in parallel or vote on results. Here you should think about speed and diversity of thoughts. If we go back here, the actual definition is LLMs can sometimes work simultaneously on a task and have their output segregated programmatically. This workflow manifests in two key variations. You have sectioning, so breaking a task into independent subtasks run in parallel, and voting, running the same task multiple times to get diverse outputs. And I like this voting part where you give the large language model the ability to run things different times. So you have different options, or another AI to have different options to choose from. A main large language model that you should consider is the orchestrator flow, where you have a main large language model that dynamically assigns subtasks. Think about it like a manager hiring on the fly. It's great for coding, great for research, great for multi-file type of edits. So here, a central large language model dynamically breaks down tasks, delegates them to worker large language models, and synthesizes their results. So you have the orchestrator that is deciding what will happen. You have a large language model, call 1, 2, and 3, and then you have a synthesizer that puts everything together back again. And here it says this workflow is well suited for complex tasks where you can't predict the subtasks needed in the examples that we mentioned. Whereas it's topographically similar, the key difference from parallelization is in its flexibility. So subtasks aren't predefined, but they are determined by the orchestrator based on a specific input. So what's different than this is that you will bring things together and synthesize all the information rather than combine everything in an aggregator sort of style. And finally, we have the evaluator optimizer model. Here, one model essentially creates, another criticizes, and together they refine, just like a writer-editor duo. And I think this is a great combination of agents working together. Each of these work in tandem, they work in production, and most don't need full agent autonomy anyway. So this is a great way to combine the best of both worlds. If we look at the diagram, this is what it looks like. So we have you have a large language model call generator, which gives the solution to a call evaluator, and then this is either accepted or it's rejected and feedback is given. You go back here, and this loop will continue until the evaluator says this is acceptable, and then you have the output. So now the question is, when do you actually need to build an agent? Because this is in my opinion, when you should do this. This is when you should build a true agent. The problem is, first of all, open-ended. You sometimes can't predict the steps, and this is a good reason, a valid reason to build an agent. And you need the model to operate over many turns. It's not like a straight line path down to the solution. Agents shine when workflows break, if they are built right. Think about customer support that pivots mid-chat, or a coding agent that is making live multi-file changes. You can't really predict what is going to happen from start to finish. There will be bumps in the road. So in other words, if you have a situation where you're pretty sure that in order to get from the start to the finish line, this isn't how it will look like, but it will look more along the lines of this in order to reach the finish line here when you have started here, then this is the kind of situation where an agent might be ideal. But with more autonomy also comes more risk, right? And sometimes even more cost, and even more room for compounding errors. So this is kind of the downside of building agents that aren't fully tested, that aren't fully maintainable. There's a lot of potential downsides as well. And Anthropic says start small, add autonomy only when needed. And I think that is a key thing that maybe most people tend to ignore. They just want to build the agent, they just want to give this out or put it out in production, sell it to clients or even for themselves, and then things break. So let's finally get into some best practices for building agents. And these are the 3 golden rules that Anthropic suggests. Number 1, keep it simple. Most agent systems that work aren't that deep. The simpler, the better. Number 2 is be transparent. So show the actions, the steps that the agent takes. And this builds trust and helps with debugging, especially when you are selling these solutions to clients. Number 3, design great tools. Write tool documentations like they are being created for a junior developer. You can't expect the AI to do something that you don't fully understand how that works. It can have autonomy, but you should still be aware, understand what the whole process is all about, where you want to get, where you're starting from. Because providing clear descriptions, clear examples, good and bad, providing common mistakes and how to deal with them. This is all very important when you are building this type of agent. And Anthropic called this the agent computer interface, or ACI. And if your tools are vague, the agent will mess up. There is no two ways around that. Anthropic also make a point about using specific frameworks to build these agents. And they mention frameworks like LangGraph and Bedrock. And they say that these help. But they also hide complexity. And that makes debugging that much harder. So Anthropic's advice is to start with a raw large language model API call and build from the ground up. Only use frameworks when you understand what is under the hood, because that is when you can really tweak and test and provide solutions when problems arise. So, as some final thoughts, here's the bottom line. Don't overbuild. Most tasks don't need agents. Start simple and only add complexity when this simple stuff fails. And finally, as Anthropic put it, success isn't about the most sophisticated system. It's about building the right one. And I think that's a super valid point, and I couldn't agree more with that. If you want help designing smart, effective systems that actually work, that is what I can help with. And if that is the case, comment below or check out the links in the description with more information on that. And don't forget to hit like and subscribe so you don't miss future videos about these topics. I'll catch you in the next one.